Okay, so we're going to build right now a system for computer science. So we know it's computer science, and let's have a look at what we've studied so far. So we've studied data representation, and we've studied, or you're studying problem solving right now. So our system is called computer science. But what we've done now is we've added two subsystems: data representation and problem solving. Can we break down data representation anymore? Yes, we can. So we're going to create another subsystem, and this subsystem is going to be, we've looked at binary numbers, and we've looked at denary numbers. So right now, our system has computer science. We've then got two subsystems. So we've broken it down. So imagine you've got a magnifying glass, and you zoomed in on computer science. You'll see inside computer science data representation and problem solving. You would also see, which we haven't covered yet, databases, internet, communication. Let's think from the top of my head. This is really bad, but I can't remember. And I will leave it like that for now. Oh, yeah. So, can we break down? Sorry, we've then got two subsystems of data representation. We've got binary and denary. So a subsystem is literally breaking down a system into smaller parts. And you're going to keep going, making subsystem after subsystem to break it down and break it down until you can't break it down anymore. So can we break down what we've done with binary? Yes, we can. We've looked at what they are. We've looked at converting to denary. And we've looked at converting numbers to binary. Same with denary. We've looked at, so a subsystem of denary would be what they are. We've then looked at converting to denary. We've then looked at converting to binary. Now the question I'm going to say is, can we create subsystems even further? Yes, we can. We can break down converting to denary into its subsystem of, how do you convert to a denary number? Write placeholder values out. Find all the ones in the binary number and add up all the placeholder values that make 1. Whoa, that is like zoomed out. There you go. So what we've created here is a subsystem of that, a subsystem of that, and a subsystem of that. So we've gone really in depth. Can we go any further converting to denary? No, we can't really. So that's done and dusted. So I'm going to say it again. A subsystem is basically the little parts which make up a whole system, and you keep creating subsystems until you can't go any further. Let me show you another example and explain it in a different way. We're going to make rock, paper, scissors, the game, the system. We're going to design it right here, right now. So let's take a magnifying glass and let's zoom right into what makes rock, paper, scissors. So, step 1, let's break down the system into the first subsystem. We're going to have users or players. We've then got another subsystem for rules. And then we've got another one which is game flow, which is basically step 1, how it's played. Step 2, what do you do next? Step 3, what happens? Step 4, what happens? Let's start with players. So what details do we need? Well, if we're making a game, let's say an app, you would need their name, probably their age, location, and their score for the game. The rules are dead simple. both players have to pick either rock, paper, scissors. Okay, let's zoom in a bit. Another rule is when the game gets to 3, well actually let's change that. When a game player wins 3 games, they win. So imagine I was playing against Grandma 11, would have as many goes until one of us wins 3 times. The game flow, how it will work. Step 1. Player 1 enters in secret either rock, paper or scissors. Player 2 enters in secret rock, paper or scissors. Game checks to see win conditions. Winner is declared. It'll say like player 1 wins, player 2 wins. Add a point for the winner. We can actually turn this into a subsystem of winner is declared. So when someone wins, it'll add a point. It'll say congratulations. I'll talk you through this in a second. And finally, if draw, no one gets a point. Okay. So we have our system broken down to subsystems. So you've got rock, paper, scissors, which is the overall system. We've broken it down into 3 subsystems: players, rules, and how the game flows. Let's talk about game flow. Player 1 enters in rock, paper, scissors. Player 2 does. The game will then check to see who wins. A winner is declared. Now, we've broken down winner is declared. What happens? Well, what happens is simple. It'll add a point for the winner. It'll say congratulations. And it also, if there's a draw, no one will get a point. What we haven't got is any information about how a player wins. So if someone enters rock and someone enters rock, what should happen? So that'll go into rules as well. So what we're going to do is, I'm going to add another rule called win conditions. Now what I'd like you to do is break that down, so win conditions, into sub-steps. Write it down. So I'll do the first one. Rock beats scissors. I'd like you to finish this off. Pause the video, finish it off. What you should have had would be scissors beats paper. Paper beats rock. Rock ties with rock, which means draws. Paper ties with paper. And scissors ties with scissors. I think that's all the conditions. Anyway, so when it gets to here, check win conditions. This part of the system will be checked. So imagine this game was in action. We load up the game. Imagine you get some really cool, sick graphics. It'll ask for our name for player 1, name for player 2, our ages, where we live, and it'll keep in the background our score. So score will start off, let's put that in there. So let's break up score into another subsystem where it starts it off at 0. Or we can put it into rules. No, let's put it here. Set as 0. That means it will start at 0. Okay. Our rules are here, which run in the background. You don't get to see the rules, they run in the background. Player 1 will be asked to enter in rock, paper, scissors. Player 2 will then do the same. The game will then check to see who wins, because it will go over to the win conditions and check all of that. It will then declare a winner, blah 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 blah. But what you have here is literally a system broken down into subsystems. Lots and lots of little subsystems. Similar to before, where we had computer science broken down. Can we break these down anymore? Probably not. No, I don't think we could. So there you go. Subsystems, it's important for you to know, are literally systems which are broken down into little parts until you cannot break it down anymore.